Algebra 1, Unit 2, Understanding Functions, Module 3, Functions and Models, Lesson 3, Modeling with Functions. Okay, today we're going to skip the warm-up and just go straight to the lesson. All right, here we go. So 3.3, Modeling with Functions, right? Let's start with the basic definition. The input of the function is the independent variable, and then output of the function is the dependent variable. Over here, guys. So on a graph such as XY coordinate system, the any input, that's the input or the domain. So the x-axis is usually considered the independent variable because that's the input. And the output depends on what the input is, right? That's a nice way to do this. And if you sort of consider y is equal to, let's say, x squared plus 1, right? Graph that kind of looks like this. Well, the y value depends on what you put in as x, right? So that's why the x is the independent variable, or the input function is the independent variable, and y that depends on the input is the dependent variable, right? So the value of the dependent variable, oopsie, uh, depends on or is a function of. So the word function of means it depends on, basically, right? It's a value of the independent variable. Okay, so for example, so let's go through the terminologies, guys. Okay, if x is an independent variable and y is a dependent variable, then we could use a function notation to write. So the y is f of x, and that's how we say it. It reads y equals f of x, so equal to f parenthesis x, close parentheses, where f is the name of the function, and we write an equation in two variables describes the function, and you could always write it this way. So dependent variable is a function of independent variable. So the independent variable, that right there is the x, and the dependent variable is the y, is equal to, and the function we would use f. Now, function doesn't have to be f. You could use the letter g, h are the next two more common ones, but I've seen u, v, w. It could be anything really, right? You're just giving a name. That's all it is. Okay. All right. Let's look at the example A here. So it says write an equation of a function notation. Amanda babysits and charges $5 an hour. So we could go straight to the function rule, but let's look at the numbers first. Okay, let's examine this and try to pretend that we didn't know this over here, and just sort of kind of deduce the function just by looking at the number. So the time that you worked is 1 hour, which gives you 5. You work 2 hours, gives you 10. 3 hours, it gives you 15. 4 gives you 20, and so on and so forth. So if we were to write this, what would you come up with? Okay, so we know that the y value is 5, then 10, then 15, then 20, right? Then function was what? It was 5 times 1, that's 5 times 2, 5 times 3, 5 times 4. You notice that these numbers are consistent, isn't it? So if they're consistent, they're either called constant. If it's a number in front of a changing value, that's the unknown, isn't it? It's called coefficient, right? And this is what's changing. Right, the input changes, right? Input could be, 1, 2, 3, or 4. That's the unknown. That's the x. So this right here is 5 times, that doesn't change, whatever the input is. And we decided to name it f of x. Therefore, f of x equal to 5x. Did that make sense? Now, so that is like trying to figure this out using the just numbers alone. And if you look at the instruction over here, let's look at that one first, okay? It implies, it says, the amount earned is 5 times number of hours worked, isn't it? The amount earned is the y-axis, which we're going to write as a function f of x. The word is equal to, and it's 5 times dot, and what are we going to call that? That's what we're going to call x, the input value, right? Now, you may use like n as a number of hours or h, hours worked, but x is fine too. Whatever you choose to use, that's the x. So we end up with 5x. So this right here, we got from this information. And this we got from recognizing the pattern that was there for the table values. Okie doke. All right. So let me do one example. Right. Let's take a look at this one right here. Okay. Example A. Here we're supposed to identify the independent and dependent variable and to write an equation in function notation for its individual situation, and then use the equation slash function to solve the problem. See, yeah, generally if we write it as f of x, right, this is for our practical purposes, that's basically means f of x. When we use the word equation, we generally mean y is equal to something, right? Blah, 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 blah. Okay. That's generally how we do it. Okay. In example A, a lawyer's fee is $180 per hour for his services. How much does the lawyer charge for 5 hours? Well, there's a dependent. So what depends here? On what? We got the dollar and the dollar amount, and we got the number of hours, right? Right. So the amount of money that you get, dollar, depends on the hours that you work, right? So this is the input, that is the output. So what we can say is let h be the number of hours that lawyer will charge you. And f of h is a lawyer's fee based on, or that's a function of, that's what it means, right? That depends on lawyer's base fee based of, on hours worked. So the function in our case, f of h, is therefore the number of hours is h, but for each hour, how much do you get paid? $180, right? Like that. And the question here was, so that's part of it. So it's asking you to find number one, find independent and dependent variables, right? Number two, equation for it, and then use the equation to solve the problem. Number three. There are 3 items here, guys. So that was number 1. So I was defining all this, and this is number 2. And how do you find number 3? How much do you charge for 5 hours? Well, we plug it in. F of 5 is $180 times 5, and that ought to give us $900. Therefore, the lawyer fee of $900 for 5 hours of service. There you go. Okie dokie. All right. I'll go with the example B, but you should maybe try it on your own. But let me do example 2, and I'll show you the answer for example B for example 1 and 2. Okay? All right, let's just visit example B first. Okay, so that's like admission fee is $9. Each ride costs $1.75. How much does it cost to go on a carnival ride? 12 rides. Oh, looks like there's an initial fee, right? Regardless of whether. So you could literally go in there and never ride, and you still have to pay $9, right? After that, you pay, doesn't it? So it's slightly different setup here. Here, no initial fee. And example B has initial fee, which is right here. That's admissions fee. That's the initial fee, right? If that's the money that you pay, whether or not you get a service, just even to get a chance to have a ride, or even have a chance to um, talk to your lawyer. One of my favorite examples that I used to use, which is now at this point outdated, is taxi rides. When you get into a taxi, generally there is a money there that you're supposed to pay immediately, and then they charge by the distance driven plus the time spent the uh, on the taxi. Well, no one really rides taxi anymore, so that example is out the window now. Okay, all right. So why don't you try that on your own and just wait for a little bit further into the video. Let's look at example two, shall we? Write a function notation for each situation, and find the reasonable domain and range for each function. Got it. It's a slightly different question, isn't it? All right. So Manuel has already sold $20 worth of ticket to the school play. He has 4 tickets left to sell at $2.50 per ticket. Write a function. Okay, hold on a second. So he already sold 20. He just needs to sell more. So function is based on total amount to be collected after what has already happened, right? Okay, get it, got it. So we want to know the total amount, but what's the amount based on though? Based on the number of tickets, right? So my my input value is the number of tickets sold. So let t is equal to the number of tickets to be sold. How's that? So the amount of money that you're going to have, f of t, is based on how much you sell and how much do you make per each ticket. It's $2.50, right? So it's $2.50. The amount they're going to make per ticket times the number of tickets, which is t, right? Plus the 20 that he already has. So that right there is the initial fee, or initial value, or initial whatever. In this case, this is the already sold. All right? And this right here is to be sold. You don't have to write the one that I write in pink. Looking at this though, but it's asking a different question. It's asking for write a function, which we did. That's number one. Okay. And then over here, it tells you to do what? Just write a function number one. And number two, find the reasonable domain and range. So part two, what is my domain and what is my range? Okay. So what is the smallest possible value of t? It's a 0, isn't it? And then you could sell anywhere all the way there to all of them, which is 4. So if you didn't sell any more, you would have $20, right? If you sell one more, that's $2.50, 20, 22.50, and another $2.50 more if you sell another one, 25, then add the same value again. So my range, my possible value of outcome, the money that I'm going to be making, my smallest is 20 that I already have, with an additional $10 to additional $10 that I could get if I sell all 4 tickets, which is $30, and then 250 starting in increments of 250 from 20 to 30, and that depends on the number of tickets that you sell, right? All right, guys, you have done enough of that, so why don't you try this on your own? To think about it, and I'll give you the answer in a second. All right, here goes. So for example, B of the example one is that, of course, the money almost always is the dependent variable, and then in this case, the number of the rides is the independent variable. So depending on the number of rides, that affects how much you're gonna pay, right? So R being the number of rides, and the F of R is $1.75 times the number of rides. That's cost per ride, right? And 9 is fixed cost. That's the entry fee. When I say cost per ride, that's $1.75. When you multiply by, you know, when you multiply by R, this is the money spent on rides, or on R rides, right? Okay. Now, if you go on 12 rides, you plug in 12 over here, right there, which I did. And when you go through the calculation, 12 times $1.75 is $21. And then plus 9 gives you $30. So I'll give you $30 to have a 12 rides. Okay. Let's look at example 2B. In this case, a telephone company charges 25 cents per minute for the first 5 minutes, plus a 45 cents connection fee. That's the initial cost, isn't it? And we have to write a function for total cost in dollars making a call. Let M, the number of minutes used, and total cost, right, is 25 cents plus 45 cents. That's 25 cents per minute, right? So total cost is F of M. F, the function that's based on M, and M is the number of minutes. And that's 25 cents per minute, so 25 cents times the number of minutes plus 45 cents. So this here is the fixed cost, or the initial cost, initial value, or whatever you want to call it. That 25 cents right there is the cost per minute. When you multiply by the number of minutes, right there, that is the money that you pay based on minutes, right? Right. Okay. So this entire thing is predicated upon the fact that you're gonna make a phone call, right? Right. So making a phone call. So I suppose it could be 0, but I'm gonna go with the fact that we actually made a phone call. So that would be our first value, 1, 2, 3, 4, up to 5 minutes, because this is good for the first 5 minutes. And then if you plug in individual value, you just have to add 25 cents to 45 cents, which gives you 70. Add another 25, gives you 90, all the way till you reach 5 over there, and that's $1.70. Okie dokie. All right, guys. All right, here's your turn. And here are the numbers. If you're at home, couldn't come to school, $7.50, $17, and $8.50. Okay. Pause the video. Try this on your own. This is supposed to be done without my help. Okay, guys. All right. So here are the answers. Last but not least, for those of you at home who worked on the what do you call this thing? Yeah, the warm up or the lesson performance task from the previous lesson. Sorry, this one right here. I'll just show you the answer. And here it is. All right, guys. I think that's about does it. And please come to tutorials if you have any questions or concerns. Right. For those of you who are absent. All right. I think we're good, right? I shall see you later. Okay. Have a good night.